How can we tell from an image whether it is a T1 or T2 weighted image, when imaging was done with a normal pulse sequence, not one of the fast sequences, which we'll hear about a little later? As a rule of thumb, if you see white fluid, for example, CSF or urine, you're dealing with a T2 weighted image. If the fluid is darker than the solids, we have a T1 or a proton density image. Look at this scan. CSF is dark. The grey matter is darker, greyer than the white matter. This is a typical T1 weighted image. In B, CSF is still dark, even though its signal intensity is slightly higher than in the T1 weighted image. Contrast between the grey and white matter is reversed. This is a proton or spin density weighted image. And as grey matter has a higher water content, in other words, contains more protons, its signal intensity is higher than that of the white matter. In C, CSF has a higher signal intensity than grey and white matter. The image is T2 weighted. These are rules of thumb only. Actually, to be really sure, you'd have to look at two images taken with different imaging parameters. Why? Look at this figure. You can see that in this example, the T2 curves start at different heights and cross each other. They do not have to run parallel, as depicted in the previous illustration, which was only done for didactic reasons, as it is easier to understand at the beginning. The fact that the curves intersect is very important. With a TE before the crossing point, TE1, tissue A will have a higher signal intensity. With a TE right at that point, TEC, we cannot distinguish the tissues at all, as they have the same signal intensity. Thus, you might be unlucky and choose a pulse sequence with just those imaging parameters that do not allow tissue differentiation, which is the reason for performing two different examinations with different T1 and T2 weightings. With a TE beyond the crossing point, TE2, tissue A will have a lower signal than tissue B. Before this crossing point, which you do not know looking at an image normally, the relative signal intensities are still governed by differences in T1. The tissue with the shorter T1, or the higher proton density if we have a long TR, still has the higher signal intensity. Only with longer TEs does the T2 weighting come up.